All right, test 3 review, everybody. Here's how I designed your other tests, and here's how I'm going to design this test. We've got, I thought I had it open. I hope it's this one. It's not letting me share. There we are. So I'm over here. I'm in my lecture notes. This is the first day of lecture after our test 2. I went over a test 2 question, and then I converted it to a Chem 141 problem. All the work here is valid work for your test. It's just this format is the next level. So please review this format. But I'm cutting to the chase here because we're at the end of the semester and everybody's stressed. This I know. Please remember, teachers included. Everybody is stressed right now. So we are going to design test by question our test here. Now, page 3 is where things really got rolling. I am going to make a question based on this question, and that way you'll have 2 answered questions to study from at minimum. Plus there's others in the in-class practice problems, which is what I used to design these in the first place. Okay, so it's going to be a double replacement reaction. This will be a big question on your test. It will be laid out like page 3 on the notes from this date, and you can't forget that because and we're going to share screen over to Starboard, this Starboard. It says right here, big question based on Starboard. There's the date, there's page 3. Can't have the wrong page there. And we're going to design it off screen, so I'm going to do a pause. And we're back to video. What we did was we designed a question over here, based directly on the one on Moodle, done the day after review day, as indicated on our new document. And we're going to take this one, and I'm using it to design your question on the test with the exact same words, except for the names of the molecules and the amounts. So we got that going on. So here we are. It's game time. I'm going to need calculators ready. There we go. Grams to moles of precipitate for each reactant. Okay. So there's a lot involved there. Let's do the balancing first. Balanced double replacement reaction for this. You need ions. I want to see everybody write ions right on their test. I get sad when I don't see it because I know your approach is you think you can get to the answer right away. Guys, you're learning from a chemist that has 30 years of teaching experience. If I don't see the ions, you're just winging it, okay? It's not about winging it. It's about systematically solving problems. Sodium ion, phosphate ion, barium ion, nitrate ion. That's why we made you learn them so early, because we keep using them all the time, right? So we're doing A in blue, and you're going to have Na3PO4. I don't need to test you on states here. It doesn't say anything about states. Leave the states blank if it doesn't say anything. But you do know how to figure out if it's a precipitate or not, because this question does have the word precipitate in it. You better know which one of the products is the precipitate. And I'm just going to tell you right now, don't pick the one with nitrate in its name. It's pretty simple. Yeah, I'm giving you a hint. One of your things will have nitrate. That won't be in the precipitate. You know that, right? I'm saving you some time here, okay? You don't even have to use the solubility table with that information I just gave you. The other one will be the precipitate, not the one with nitrate, the one with phosphate in this question. All right, barium nitrate coming right up. Plus, you need 1 barium and 2 nitrates. They react to give, oh yeah, sorry about the angle here. I think we can get through that. Mix and match Na with NO3, you get a 1-to-1. I won't be asking for states because I didn't ask for states here. But you know that's dissolved in water, right? Barium is hooking up with phosphate. That's a 3 barium and a 2 phosphate. Definitely a precipitate. I'm going to write S here. I wasn't asked for it, but now I know that's the precipitate, right? Right there. And now you balance, right? We know the drill. Don't balance till the end. I hope I'm sounding like what they call a broken record. You know, I have no idea what that means nowadays because we don't use those records. Okay, sodium is a problem, but if I put a 3 here, I'm going to backtrack on that. Because how are you going to balance the nitrates when there's a 3 there and a 2 on the left side now? I've recognized this is a common multiple issue. Have you? As soon as I put that 3 there, there's 3 NO3s. You can't balance 3 NO3s with 2 NO3s without doing a common multiple. That's going to be a 6. And yes, this is one level harder than the one in the starboard activity. I'll try to go back to the level of the starboard activity for your test. Yeah, this is the level that's one harder. You had to recognize a common multiple. Now, where else do we need numbers right now? Sodium situation is not fixed, is it? You need a 2, and I believe it's fixed. It's all done now. Good. Now we're going to do our steps. Grams to moles of precipitate for each reactant. So 1.234 grams of sodium phosphate means you're going to need what for that, and eventually what for this? If you're going to do this step, go from grams to moles for the reactants. What do you need for this before you can start? Formula weights. So I'll set them up and then we'll go off screen. 22.99 plus phosphorus I can't read. I need somebody to read it right now. What is phosphorus, please? 30.97. Can somebody correct that? That's closer if it needs correcting. Perfect, thank you. And then barium over there. Barium, BA, far left near the bottom. 137.3. We're 4 sig figs on ours. I'm keeping it 4 sig figs here. And 2 times 14. 0.01 plus 6 times 16.00. We have all the stuff we need here now. Formula weight, 3 times barium, 137.3, plus 2 times phosphorus, which is 30.97, plus 8 times 16.00. We're pausing and getting all these answers for you. Your screen sharing is paused. Great. I don't think we saw any of this. Just coming back. We're recording. I just want to make sure you see what I was talking about. I apologize. I just found out I was paused. I need formula weights for the 2 reactants and the precipitate. You will need these formula weights. You can, as soon as you realize that this is the question, why don't you stop reading and get those formula weights, you know? Because you get a point for each one. You don't need anything for this one. But you can't ignore this thing. It was necessary for the balancing, right? But after you balanced it, you're not concerned about this chemical at all anymore. All right. And we're going to stop share. We're going to pause. All right, we're back. We had a small mistake on one of the formulas, formula weights. This was a 2 by mistake. I used a coefficient by mistake in a formula. That's nuts. That 2 is only used to go from moles of this to moles of something else. We're not even at moles yet. You can't use it. There are 3 sodiums in the formula, not 2. I fixed it. There's the formula weight. There's this formula weight. There's this formula weight. Now we're ready to go from grams to moles of precipitate for each reactant. We have 1.234 grams times 1 mole for every 163.94 grams. Do not write down the answer. Coefficient time. 1 mole PPT for 2 mole, they're blue, all low. They're blue. 2 mole Na3PO4. And somebody got that for me? Mole PPT. And now we're going to do the other one underneath. So we got this guy. We took care of it there. This guy we're going to take care of down here. So we had, it's in green, 1.345 grams. Na3PO4. 1 mole for every 261.32 grams. Times 1 mole PPT for what? 3 mole Na3PO4, is that correct? No, BaNO3 twice, sorry. Forgot what chemical. What? You guys would have caught me eventually, right? We're not talking about Na3PO4 there. What are we talking about? Yeah, BaNO3 twice. Don't worry, it was just a labeling error. There was no math error. Caught myself because I was writing it down. I wouldn't have caught myself if I didn't write it down. And let's see, is it a bigger number or a smaller number than the other one? 0.001? Yep. Oh, what a guess. Okay.
71565.
Oh. We have a winner, right? That is the theoretical yield, correct? Because it is smaller than this number here. So that's the only one that counts, and it makes this yeah, I love you too. Sorry. Makes this the, what's the chemical that runs out first? Limiting reactant. What's with that big arrow? Well, you got to figure out the smaller number first. So I was here when I made my decision about this. If this was the smaller number, I would have pointed back here and said sodium phosphate is limiting. And once again, I should have written Na3PO4. That might have prevented my earlier mistake if I had that already on the screen. Okay, so we're well on our way. Now, we're going to go grams to moles for actual yield. So I got grams. I'm going to take that and go to moles. So B was down here. It started right here. Continued here. C, I'm going to take my 0.8765, 8765 grams PPT times 1 mole for every 601.84 grams. And you're going to get a tiny number, much less than 0.001, I hope. Please. This is when I have to cross my fingers.
145.
Oh, good. It was closer than I thought, actually. Give me 2 more sig figs at least. Give me more.
637.
And that is now in moles, right?
It's 145,637.
145,637? Got it. Percent yield, big finish. Don't forget this was actual. It says up in the question, it says this was actual, right? I hope. Actually made, yes, yes. Actual yield. 0.0014567 over. I can't even read the number anymore. 00171,565 times 100. You got it for me? Excellent. That's a lot of points, this question.